Hi, this is Vivek. Recently, I came across a beautiful website called puzzleprime.com, which has amazing collection of puzzles of various types and difficulties. If you love puzzles, you would love to visit that site. While I was browsing in that site, I came across a beautiful puzzle which captivated me for days. Working on that puzzle gives some amazing insights and exciting results, and that is the story of this video series. I'm going to share my excitement with you. We are even going to do some programming stuffs in the middle, so this is going to be awesome. Let us begin. Let me call this puzzle as 3 heads problem. There is already a famous 3 heads problem, but this one is different. Anyway, let us call this as 3 heads problem. The puzzle is as follows. Professor Joseph calls his 3 students Albert, Brinda and Cain. He puts a hat on each of their head. Then he writes a positive integer on each of the hats. Let us call those integers as A, B and C respectively. Just the first letter of their names. Now each person can see the other 2 numbers but can't see his own. For example, Albert can see the values of B and C but does not know his own number A. Similarly, each one sees other 2 numbers but does not know his own. Now the professor says, one of your number is the sum of the other 2. That is, A equal to B plus C, or B equal to A plus C, or C equal to A plus B. Having said that, now he asks Albert, Brinda and Cain in order whether they know their own number. In the first round, he asks Albert, do you know your number? Albert replies, I don't know. Then he asks Brinda. She too replies, I don't know. Then he asks Cain. He too replies, I don't know. Then the professor goes for another round. He asks Albert again, do you know your number? Albert again says, I don't know. Then he asks Brinda again. She again says, I don't know. Then he asks Cain again. This time Cain says, yes, my number is 144. Now the question is, what are the other numbers? So each number is a non-zero positive integer. One of the numbers is the sum of the other 2, and this conversation happens with Cain finally claiming his number to be 144 in the second round. That is C equal to 144. So what are A and B? In this part 1 video, I am not going to tell the complete answer. Anyway, if you want to give it a try, feel free to pause now. Okay. First, let me reveal the answer as given in the puzzle side. The other numbers are 36 and 108, but we can't be sure which is which. Either A equal to 36 and B equal to 108, or A equal to 108 and B equal to 36. We will see the reasoning behind it. Yet this solution is not complete. There are actually 5 possible solutions. So there are 3 other solutions. Before getting to the solution in this video, let us make some observations and consider some simple scenarios to see what is going on to understand the problem better. Let us begin with observations. It is mentioned that one of the number is the sum of the other 2. So each person deduces his number to 2 possibilities. For example, consider Albert. His number A can be either the sum of the other 2, that is B plus C, or A added with some other number gives a that number, that is A plus B equal to C or A plus C equal to B, that is A equal to C minus B or B minus C. Since A is positive, A is equal to absolute difference of B and C, just absolute value of B minus C. So Albert deduces that his number can be either B plus C or absolute difference of B and C. Similarly, each one reduces their number to two possibilities. So, b equal to a plus c, or absolute value of a minus c, and c equal to a plus b, or absolute difference of a and b. Now, note that absolute difference value can be 0. If that is the case, that option can be rejected, as we all know that each number is a non-zero positive integer. The implication is that if b equal to c, then Albert is sure a equal to b plus c, as b minus c equal to 0. That is, if Albert sees that other two numbers are equal, then he can claim his number to be their sum. Others too follow the same. If someone sees other numbers are equal, then he can right away claim his number as their sum. But as we have seen in the first round, all the three have said I don't know. So this implies that all the numbers are different. So these are some observations. Now let us consider some simple scenarios to understand what is going on. First, let us consider the scenario when the conversation ends in the first step itself. Let a equal to 2, b equal to 1 and c equal to 1. So Albert sees b equal to 1, c equal to 1. So he right away deduces his number to be 1 plus 1, that is 2. So in the first step itself, when asked, Albert claims his number to be 2. Now let us consider the scenario when the conversation ends in the second step. This can be as simple as the first scenario. Like if a equal to c, then Brinda right away can guess her number to be their sum. But let us consider a little bit twisted scenario. Let a equal to 2, b equal to 3 and c equal to 1. So in the first step itself, Albert sees b equal to 3, c equal to 1. Since they are different, Albert is not sure of his number. So when asked, he says, I don't know my number. In the second step, Brinda sees a equal to 2, c equal to 1. So she deduces her number to be either 2 plus 1 or 2 minus 1, that is 3 or 1. She considers the case, what if her number is 3? Then Albert would have seen b equal to 3 and c equal to 1. So as the numbers were different, Albert would have said, I don't know. Now she considers the second case. What if her number is 1? Then Albert would have seen b equal to 1, c equal to 1. So as the numbers were equal, Albert would have deduced his number to be their sum, that is 1 plus 1, that is 2. So in the first step itself, Albert would have claimed his number to be 2, and that has not happened. So Brinda deduces that her number can't be 1. So in the second step, she claims my number is 3. So this scenario ends in the second conversation. Now let us go little deeper. Our third scenario ends with the third conversation. Let a equal to 2, b equal to 3 and c equal to 5. So in the first step, Albert sees b equal to 3, c equal to 5. Since they are different, Albert says, I don't know. In the second step, Brinda sees a equal to 2, c equal to 5. So she guesses a number to be either 2 plus 5 or 5 minus 2, that is 7 or 3. Now she considers each case. First, what if a number is 7? Then Albert would have seen b equal to 7, c equal to 5. As they were different, Albert would have said, I don't know. So the next case, what if a number is 3? Then Albert would have seen b equal to 3 and c equal to 5. As they were different, Albert would have said, I don't know. So in any case, Albert would have said, I don't know. So Brinda cannot deduce a number, so she says, I don't know. In the third step, Cain sees a equal to 2, b equal to 3. So he deduces his numbers to be either 2 plus 3 or 3 minus 2, that is 5 or 1. He considers each case. First, what if his number is 5? Then, in the first step, Albert would have seen b equal to 3, c equal to 5. As the numbers were different, Albert would have said, I don't know. In the next step, Brinda would have seen a equal to 2 and c equal to 5. She would have reduced her number to be either 2 plus 5 or 5 minus 2, that is 7 or 3. Then she would have considered those both cases, and she would have seen that both cases would have resulted in Albert claiming, I don't know. As you can see, b is not equal to 5, that is b is not equal to c. So Albert would have said, I don't know. So Brinda would have said, I don't know. So Cain considers the second case. What if his number is 1? Then in the first step, Albert would have seen b equal to 3 and c equal to 1. As the numbers were different, Albert would have said, I don't know. In the second step, Brinda would have seen a equal to 2 and c equal to 1. So Brinda would have guessed her numbers to be either 2 plus 1 or 2 minus 1, that is 3 or 1. But if a number was 1, in the first step itself, Albert would have seen b equal to 1 and c equal to 1. As the numbers were same, Albert would have claimed his number to be 1 plus 1, that is 2. But as that had not happened, Brinda would have deduced that her number could not be 1. So in the second step, Brinda would have claimed her number to be 3, but that too has not happened. So Cain deduces that his number can't be 1. So he says, my number is 5. So this scenario ends in the third conversation with Cain claiming his number to be 5. Now we have seen what is going on. Now we understand the complexity involved. So let us end this part 1 with this. In the next part, we are going to find all the solutions for the original problem with one surprising twist. What if the numbers can be any non-zero positive numbers rather than just positive integers? Keep pondering. Thank you.